be going on. And in going on, we are going to be doing rational something, fractions. Stuff to do with fractions. Simplifying fractions. Okay, today we'll focus on simplifying, multiplying, and dividing. So we're going to simplify rationals with a focus on multiplication and division. And then later we'll get to addition and subtraction. Addition and subtraction a little bit harder. Alright, anyway, so we're going to simplify these. Let's recall, well, how do we do a multiplication and division of a fraction? So the same concepts that deal with regular fractions deal with these expressions. So if I have, now I'm not going to multiply or divide anything, I have 12 over 5 here. And we know that we would not leave this 12 over 15. We wouldn't leave this 12 over 15. We would reduce it, right? We would simplify it. And what we end up doing, what you're taught in elementary school, is to do this. Like you divide the top by the same thing as you divide the bottom. Something like this. So you get 4 over 5. But what's really going on here is that we have prime factorized the 12. And we get 2 squared times 3. And then we have prime factorized the 15, and we get 3 times 5. And then we are going to cancel. Let's not start the yawning thing. Alright, we're going to cross cancel, and then we get 4 over 5. That's the same thing. So that's what is actually going on when we're simplifying rationals. We've factored, and then we've canceled. So what we are going to do for these is, if I have like x squared plus 3x, and maybe that's over x squared minus 9, I'm going to do the same basic process. I'm going to factor, then cancel entire groups. Alright, so I'll factor my numerator to x, and x comes out, and then I have an x plus 3. And then in the denominator, when I factor that, I get x plus 3 and x minus 3. Do we all see that? I'll take that as a yes. Alright, then I'm going to cross cancel. Now I have entire groups. I'm going to cancel the entire group x plus 3 and the entire group x plus 3 there. And that's going to lead me towards my answer, x over x minus 3. Okay, that's the simplified thing. Alright. Do you need to see another one like that? Maybe one more? Maybe 2 more. Why not? We'll do 2 of them. Okay, so we're going to simplify these fractions. So I'm going to factor the numerator of the first one. What do I get?
4. This is x minus 3.
And on the bottom?
8. This is x plus 3.
Okay. Now I have to cancel entire groups. I can't cancel the x minus 3 and x plus 3. But I can cancel the 4 and the 8. So my answer is going to be x minus 3.
Mr. Kenny,
Yes.
could you ask Troy to come to the desk, please?
He's gone on to a different class.
Thank you.
Any questions on that one? All right, how do we do the second one? Factor. All right, so we factor, we'll get x plus 3, x plus 2, all over x minus 1, x plus 3. And now we cancel. We can cancel the entire group x plus 3, and that's going to leave us with x plus 2 over x minus 1. Sometimes simpler questions are harder, so let me do a simple one. These are the most complicated. Like the examples I've given you are the more complicated examples. Do you understand what we're doing? We're the complicated examples? Are we good? Mm-hmm. Your silence is intriguing. All right, let's say I have 6x squared plus 12x all over 4x, like that. Okay, so this is the simple example, but sometimes it's the simple things that destroy us. What can I factor? I do it the same way. Just because I only have one term down here doesn't change anything that I do. What can I factor out of the numerator? And then the numerator, I don't have anything that I can factor, so it just stays the same. I can cancel, now I can cancel the 6 and the 4, divide them both by 2, and I can cancel the x's completely. So my final answer is 3 times x plus 2 all over 2. Now you have to read the directions to know whether you would distribute that 3 or not, but for now we'll assume leave it in factored form, unless you were told otherwise. Yeah, I'm pretty sure they are all left in factored form. Okay, so that is reducing. There's only one more thing to be said with reducing, and actually for any of these problems, that's restrictions. Restrictions are whenever the denominator equals 0. Okay? Because you cannot have a denominator 0. And let's tie that to what we did the last few sections. We talked about vertical asymptotes and holes. Whenever we have a denominator equals 0, we either have a vertical asymptote or a hole. One of those we have, depending upon what's in the numerator. When we're simplifying these and we're considering our restrictions, we don't even care what cancels. We just want to know whenever our denominator is 0. So what we would do is we'd go back. Let's go back to each of these. So I'm going to go back to this one, and I would look at this denominator. And if I wanted to state restrictions on this, I would say, well, x squared minus 9, that cannot be 0. I would factor that, just like I already did. And say that can't be 0, which means x can't be negative 3 and x can't be 3. And these are my restrictions. It's basically what you've already done as far as finding vertical asymptotes, but this is telling us what our answers cannot be when we start to solve these. So let's go to this one. This denominator could not be 0. I don't care what happens after I factored it and canceled, because there's a hole there. Regardless of what happens, there is a hole there. So I'd say 8x plus 24 cannot be 0. 8x cannot be negative 24. And x cannot be negative 3. So this is the restriction on that answer. If I take a look at this example, that denominator cannot be 0. So I'd say x squared plus 2x minus 3. That cannot be 0. I factor it. We have already factored it one time. I mean, ultimately, when you're doing these, you're only going to factor them once. You can just reuse it, you know. So x can't be 1, and x can't be negative 3. And I check my restrictions before I start simplifying. So these are my restrictions. All right, in this one, x can't be 0. X is not 0. 4x equals 0, okay? So restrictions are whenever the denominators equal 0. So whenever you ask that, no matter the problem, you check all your denominators like I just did. All right, let's go to multiplication and division. So let's recall. Well, how do we multiply and divide fractions? So there are going to be basically 3 cases that I'm going to go over. So let's say, well, maybe 4. Let's say I have 5 and 1/2 times, let's say 1 and 1/11. So whenever we are multiplying, we need to switch to mixed numbers to improper fractions. So I get 11 over 2 times 12 over 11. And then what we learned to do in previous classes is we would cancel those. We cancel those. And top times top is 6, bottom times bottom is 1. You're going to want to know how to do fractions and decimals and things by hand because those are common questions on college entrance exams. So whether you got accepted to college or you know, whatever standing you enter into, you as a freshman will go in early. You will take a test and they'll see what do you actually know how to do versus what was on your transcript, because they tend to not believe high school is what we say you know. So they will test you and they might put just fractions on there, and if you don't know how to do them, they'll say, you're not ready for college math, we need you to do this extra class for no credit to get you ready. So you'll want to know how to do these, of course. So let's say I was dividing. What if I were taking 3/4 divided by, let's say, 3/8? Okay, now we'll go ahead and do the quick way, the keep flip change. I explained the quick way is working because division is the opposite of multiplication, so why not flip this? You know, make it the opposite. And then we see I kept the first fraction, flip the second fraction, switch to multiplication. So we're going to cross cancel, and then we'll cancel these. And top times top is 2. And bottom times bottom is 1, so 2. Okay? So even if we have a complicated expression, we are going to do the same things. Whatever we do for regular fractions, we do for these complicated expressions. Now there is one more that I want to talk about. What if I had 3/5 all over, say, 5/6? This is called a complex fraction because it's a fraction within a fraction. Now if this were just a whole number, say it was just 5, then I'd put it over 1 just to complete it. This fraction bar means to divide. So I'm going to change it to a division problem. I'd say 3/5 divided by 5/6. Then I'd keep, and I'd flip and change to multiplication. Now I see nothing cancel, so I get 18 over 25. Now I did go through that fast, but this should be, all of that should be something you've done since like 5th grade, okay? And if not, your 5th grade teacher or whatever, or you forgot, you know, what they told you. Probably you forgot, because I guarantee they talked about this. Maybe not the complex fraction, but the rest of it they did. I know they did. All right. Now let's do a multiplication. Let's say I had x squared minus 1 all over, let's say, x squared minus 4 times, let's say, x squared plus, let's do 5x plus 6, just for fun, why not? And let's say we have x squared plus x minus 2. Now, we are going to do the same things that we did before. We're generally going to factor. So we'll factor our numerator. We factor our denominator. We following along here? Getting this down. We factor those times. We keep it times. Factor our numerator on the next fraction. And this fraction. So we're going to factor. We are then going to cancel, and then we'll multiply or divide, whichever we are doing. So since we're multiplying, we can cancel a few things. We can cross cancel. We can cancel the x minus 1 and the x minus 1 there. X plus 2, those cross cancel. I could cancel it right here, by the way. That's fine. Do you see what I'm saying? I could cancel it right there. It doesn't matter. And then in the end, my answer is no more canceling. I cannot cancel sideways. You see what I'm saying? Could I cancel like that?
Well, couldn't you cancel, like, not sideways, but the x plus 2 down there with the x plus 2 on the top, and then x plus 2 down there with the x plus 2 on the top? Or can you only cancel once?
This is gone. This is changed. So, what's that changed to now? A 1. I can't do it again, because this isn't x plus 2 anymore. It's a 1. Alright, so top, x plus 1, x plus 3, x plus 2, x minus 2. Now, depending upon our directions, we might leave it like this or we might multiply out. It just depends. So for now, we'll just leave it in factored form. This is called factored form, by the way. If I say expanded form, let's say I said that. Expanded form means I'm going to actually multiply it out. In that case, I get x squared plus 3x. Nope, not 3x. 4x in the end, plus 3. All over x squared minus 4. And then that's the expanded form. This is factored form. This is expanded form. Okay, let's do a division. A wonderful division.
So will we have homework tonight in this, or is that what tomorrow's homework is?
This is tomorrow's one. All right, let's go ahead and do this one. What do we do first? And as I'm doing that, actually, I'm also going to do what? Factor. I can do it all in one step. So I need to remember as I factor that I'm going to flip around where everything is. So this one actually ended up right here, and this one's going to end up right here because I'm KFC, keep flip change. 1 and 1, plus, minus. Okay, we'll cross cancel one time, the x plus 2 one time. Boy, I would love to do the x plus 1 and the x minus 1, but I can't. I could do this 2x plus 1 and this 2x plus 1. So that gives me x plus 1, x minus 1. But I want to think before I continue on. And actually, that's our last example. Pretty much our last example. Oh, no, one more thing. One more. 51. We want to think of the restrictions. So I go back to the beginning when I'm asked for the restrictions. I look at my denominators. That can't be 0, and that can't be 0. Now, I've already factored them. So the factoring for this one ended up right here. So I'd say x can't be 1/2, and x can't be negative 1/2, And when I look at the factoring for this one, it ended up on top here. Now this one is also a half, but this one is 1. So I don't need to write the half twice. And those are my restrictions. I go back to the beginning for the restrictions.
Why do you do that though? What's the point?
To know when, if the denominator is 0, this is not defined. Okay, so if I have 4 over 0, well, what is that? That's taking, what is that? Taking 4 pieces of candy and dividing them into, giving them to 0 people. That makes no sense. That's that, and if you want, it's an infinitely big number. If I put in 4 divided by, would you agree, 0.00000000001, would you agree that that's an awfully, that number's awfully close to 0? If I put that in my calculator, I'm going to get actually an astronomically big number. And the closer I get to 0, the bigger that fraction gets. So that's undefined. It makes no sense. I mean, I would be giving infinite candies to 0 people. It makes no sense whatsoever. So we don't want that. So even though, this is why we talked about removable discontinuities, everything that we canceled is removable. And that takes what might be like a jagged, horrible thing with holes in it, and it smooths it over. Okay, so it's not horrible and jagged anymore. Connects it. Well, I wouldn't connect that. You can't remove an asymptote. Okay, one more type. The complex fraction case. Let's go ahead and do that because that tends to be annoying. Because it looks really, really nasty. But in reality, it's not that bad. It's just the same thing written a different way. Okay, I'm going to factor. See, this means to do what? Divide. So, I'm going to factor my first fraction. Factor my second fraction. Got to do it properly, though. Now I'm going to keep flip change. So this is going to flip around, right? This one flips. So this x plus 8, x squared plus 8x plus 15, when I factor that, that's going to end up in my numerator. Okay, and then we'll go ahead and cross cancel. So the x minus 1 should cancel. The x plus 3's cancel. That's it. So what's our answer? X plus 1 times x plus 5. X minus 3. X plus 4. Now, I don't look at my restrictions from middle steps because I'm doing a lot of different manipulations here, so I don't want to do that. That's why we go back to the beginning. And we would say this fraction, that can't be 0.
You just say it can't equal 0?
Yeah, x squared minus 9, that can't be 0. So then I factor that. I've already factored it, so I don't need to factor it again. But I did. And I say x is not 3. X is not negative 3. And then I do the same thing for this one. See, everything I did in black here is a restriction, and I'm not going to factor that a second time. It can't be negative 3. It can't be negative 5 either. And I don't need to list negative 3 twice. All right, that's it. So you can put away your notes and go ahead and grab the whiteboard. Yeah, do that if you haven't already.